Good morning, ladies and gentlemen. This is Mr. Rowe looking geometry part B. This is lesson 3. We're going to talk about the Pythagorean theorem and special right triangles. I'm going to show you a similar example to the computational problems that you have to do. I'm not going to show you similar examples to the word problems. Use the ones that are in the lesson. So basically what I'm going to do here is I'm going to talk through some of the examples that are actually in the lesson and show you how they fit with the examples of the assignment problems. So for numbers 1 through 4, you're applying the Pythagorean theorem, which is a squared plus b squared equals c squared. And you're just trying to figure out the missing side. So depending on what you're given, that tells you how to solve. So if we look at this first example right here, I look at the right angle always to start off with. The right angle touches both of the legs. The legs are A and B. Now, it doesn't matter which one A and B are, they're interchangeable. But we're just going to substitute into the Pythagorean theorem with the information that we have. I know that 6 is a leg and 8 is a leg. So I'm just going to substitute in 6 squared plus 8 squared equals c squared. Well, I don't know c, so that's my value for x. And then I'm just going to solve. I'm going to square both of these things. If you need a calculator, get your calculator out. It doesn't really matter what kind of calculator you have. As long as it has a square root function, you'll be fine. So here's my calculator. 6 squared, I know that. That's 36. 8 squared is 64. I'm trying to find x squared. So now it's just a matter of just follow what I have to do here. I have to add. So 64 plus 36 is 100. And here on any Pythagorean theorem problem, the last step is to find a square root. So we're going to find the square root of these things. And again, this is where you'll want to use your calculator because they don't always work out to be nice even numbers, and that's fine. Just round to the nearest tenth, like it says to do in the problem. So I'm going to put this on maybe. There we go. Now I'm just going to find the square root of 100. I know it's 10, but I'm just going to show you that's how you do it in the calculator. Mr. Rowe. There you go. And so that's 10. Now, if it's a decimal, just round to the nearest tenth. Otherwise, leave it as the whole number. I know number 4 says to leave as a simplified radical, but I'm really not making you do that for these problems. So let's look at this example. Again, I want to find the right angle. The right angle is always listed. It's right there. So that means this is a leg and this is a leg. That means one of my legs is x. So a squared plus b squared equals c squared. I'm just substituting what I know. X squared plus 5 squared is going to equal 13 squared. And again, I'm just going to simplify using orders of operations and then do an inverse operation to solve and then take a square root. So 5 squared, 25. 13 squared is 169. Again, if you don't know those, use your calculator. I'm going to subtract 25 from each side. That gives me 144. And again, the last step on any one of these problems is to find a square root. And again, use your calculator. And if you don't know it, just get it. If it's a decimal, just leave it as a decimal. And the square root of 144 is 12. And so there you go. That's how you do numbers 1 through 4. One of those two will apply to all 4. I'll go ahead and tell you the first 2 are like the first example I did. The second 2 are like this example. So just solve them just like I showed you. All right, so 5 and 6. Would these make a right triangle is the question. So what do you do here? You're just going to apply Pythagorean theorem. A squared plus b squared. Instead of an equal to sign, we're kind of just putting a question mark there. If they equal, then it is a Pythagorean triple. That makes it a right triangle. I'm going to substitute these values in. Remember that the longest number, or the biggest number, is always c. So in this case, 17 is c. And so I'm going to substitute 8 squared plus 15 squared, question mark, and does that equal 17 squared? And so this is where, again, pull out your calculator. 8 squared is 64. 15 squared is 225. 17 squared, I know it's 289, but, let's just show you 17 squared, just like that, 289. And now, does this equal 289? Well, 64 plus 225 is 289. So that does equal 289. So yes, this is a right triangle. Okay, let's look at this example. Be careful, check the order, make sure that the numbers are right. 14 right here, and that's going to be my C. 11 squared plus 6 squared equals 14 squared. 11 squared is 121. 6 squared is 36. 14 squared, again, 14 squared, 196. Does 121 plus 36 equal 196? Well, 121 plus 36, that equals 157. That does not equal 196, so this is not a right triangle. So that's how you're going to do numbers 5 and 6. Just follow those processes. If they happen to equal, then yes, it is a right triangle. If they do not equal, no, it is not a right triangle. Okay, numbers 7 and 8. We're basically applying this rule from the lesson that says if c squared is less than a squared plus b squared, then it's an acute triangle. If c squared is greater than a squared plus b squared, then it's an obtuse triangle. If they're equal, we just did those, that's a right triangle. So we're just going to do a couple of these just so we can see. So I'm going to start with A right here. And again, 14 is the hypotenuse. So I'm going to do 6 squared plus 11 squared. And I'm going to put a question mark there. 14 squared. 6 squared is 36. Matter of fact, this is the example we just did. Now we're going to determine whether or not it's obtuse or acute. And then we got 14 squared is 196. We figured out that this was 157. And 157, which is a squared plus b squared, is less than c squared, which is 196. So that makes this an obtuse triangle. So that's how you're going to work those out. And you can check all those as well. I'm only going to do one example because it's basically the same thing. So just substitute in and then see which one of these two rules apply. Okay, number 9 and 10, we're trying to use the special right triangle rules. There's two types of special right triangles. There's a 45, 45, 90, a 30, 60, 90. 45, 45, 90 has this set of ratios, which is 1 to 1, square root of 2. So that means the two legs are equal. And to get the hypotenuse, you take one of the legs, multiply it by the square root of 2. So in this example right here, what do I know? Here's my right angle. I know that this is a leg and this is a leg. That means that n, since it's a leg, has to also equal 6. And then how do I find m? Well, to find m, I'm just going to take the leg, multiply it by the square root of 2. Now, don't go putting this in the calculator. Just leave it just like that. That's the reason that we use the special right triangle rules. Okay, and then let's look at the second example here. This will be exactly like number 10 in the lesson. Again, we know that the legs have to be the same. So here's my right angle. So that means this is a leg and this is a leg. That makes this the hypotenuse. Well, the hypotenuse is equal to a leg times the square root of 2. So we're going to use that to help us figure out what one of the legs is. So 18 is going to equal a leg times the square root of 2. Now, this is where you're going to have to be very specific. I'm not going to accept decimal answers for this because the reason that we do this is so that we get exact answers. Okay, so we're going to divide by the square root of 2. And we can't leave this like that, so we have to simplify the radical. That's a real easy step. I'm just going to multiply by the square root of 2 over the square root of 2. I talk about this in the lesson while you do that. And so we end up with 18 square root of 2 over square root of 2 times the square root of 2 is the square root of 4. This gives me 18 square root of 2 over 2. And so now I can simplify that to give me 9 square root 2. So just follow that example. It's real simple. Don't make this part any harder than it is. Just multiply straight across, and they're going to all end up pretty much being this similar work. So follow that example. And then numbers 11 and 12. These are the 30, 60, 90 right triangles. So 30, 60, 90 is 1 square root of 3, 2. So I'm going to show you how these work. My goal with all of these is to get this short leg first. Once I know a short leg, it's 2 easy steps to get the other 2. So let's start with this example. And this will be just like number 11. What do you know? I know that this is a leg and this is a leg. 30 is X, so this is the short leg. 60 is across from Y, so this is the long leg. And here's what I know. I know that this is the hypotenuse. Let's get that. So I know that the hypotenuse is equal to 2 times the short leg. So 2 times short is the hypotenuse. So what's the hypotenuse in this case? The hypotenuse is 6. And I'm going to change that to the X, which is in the problem. And so this is just really a one-step equation here. I'm going to divide by 2, so that makes X equal to 6. So now how do you go from short leg, which I told you, you know the short leg, the other two are real easy. How do I go from short leg to long leg? That's a real easy process. Go from short leg to long leg. The long leg is equal to short leg times the square root of 3. So I know the short leg now. Short leg's 6. So I know that my long leg, which in this case is going to be y. Y is going to equal the short leg times the square root of 3. Look at that, it's done. And that's the 2 answers. So let's look at this second example. Again, go through this process every time. There's a right angle, so that makes this a leg, this a leg. There's 30, so that makes this the short leg. That makes this the long leg. And then this is the hypotenuse. So what do I know? I know the short leg. So I know that the hypotenuse is equal to 2 times the short leg. We just went over that in the last problem. So my hypotenuse here will be 2 times 4. So my hypotenuse is going to equal 8. Okay, I know the hypotenuse now, and I know the short leg. So what's the long leg? The long leg is the short leg times the square root of 3. So that's real simple too. I'm just going to substitute what I know. Short leg is 4. And look at that, we're done. So I hope this helps you with the Pythagorean theorem and special right triangles in lesson 3. If you still struggle with this as you're working, please let me know through teacher message or make an appointment for a help.